Power supply. We were originally going to try to do two 1600 watt power supplies inside this guy, but we found there isn't space for it. We would have to do something pretty fancy to be able to make that work. So we're going to stick with the one in this particular case. It's titanium rated, which means that it's good for 94% of its faceplate value as continuous load. For 1600 watts, that's a little over 1500 watts continuous supported. So we can crank this baby up pretty high, and it'll be very comfortable sitting in that range. And it can handle spikes at, in brief periods of time, up to the 1600 watt window. So a little power calculation on the individual components that we have again real quick, just as like a mental math check. 600 watt GPU, 600 watt GPU, CPU that when it maxes out can get as high as 350 watts. So between those three major power consuming components, we could hit 1550 watts if just everything's just going bananas and just going crazy all at the same time. Then we're going to have things like boards, peripherals, fans, stuff like that. That could add roughly another 100 watts to the equation. So that would then take us to anywhere from 1650 watts to maybe 1675 watts. And again, that's if every single one of our components was just going bananas and just all having a party at the same time. In traditional inference, this doesn't really happen very often. Usually when inference is happening, when the LLM's doing its work, the GPUs are going crazy. They're working really hard. The CPU is usually in the back room somewhere having a cappuccino and relaxing. So it's very rare that you're going to get 100% draw on the CPU and 100% draw on the GPUs all at the same time. Even in training loads, this doesn't typically happen. This can increase a bit on agentic tasks because the LLM is going to be doing read and write operations to individual files or creating files or accessing things, which is going to introduce a little bit more work on the CPU. But traditionally, you're just never going to see all of these things drawing max power at the same time. So for our particular case, 1600 watt titanium power supply is probably plenty. All we would have to do, just to be extra super duper safe, is do a slight power cap on the individual GPUs, which probably makes sense thermally anyway. You've got two 600 watt GPUs all plugged together into a board and hanging out inside this chassis. It's probably not the worst idea in the world to shave them by, say, 50 watts, or in this case, less than 10%. So for maybe like a 10% drop in peak wattage on the GPU, we could fit all of this in here safely. Even if everything was having a party, it fits inside that 1600 watt envelope, and we're probably never going to get there in practice. So not a big deal, but worth noting. If you were planning to put two 1600 watt GPUs into this guy, just structurally and space-wise, it's not as friendly with 9000D on the Corsair. Now, just brief overview real quick. Mike, why aren't we doing 2000 watt power supply? That seems more than doable. Why wouldn't we just put that in here? I don't like a lot of the options that are out there for 2000 watts. When you start looking at some of the larger power supplies, you encounter a couple of different things. One, a lot of them assume that you're going to be feeding them, 208 or 240 volt power. I don't have that in this room. I have 120 volt outlets like a normal human person, and I don't have these big high voltage power connections. So be mindful when you look at power supplies online that might say 2000 watts. First thing, well, 2000 watts at what power or at what what individual voltage. 2000 watts at 120, sure, okay, that's useful, that's interesting. But a lot of these power supplies, you'll see them advertised at like 2500 watts, and then you'll note that it assumes 240 power supply or 208 power supply. And in that particular case, then it becomes like a 1500 watt platinum rated power supply at 120 volts. So in many cases, this 1600 watt, 120 volt titanium rated power supply actually takes the cake. It's pretty awesome for what it does and for the voltage that it can operate at. The other thing worth noting is the individual power supply ratings. So even if you did have, say, like a 2000 watt power supply running off of 208 volts or 240 volts, if it's titanium rated, which most of them aren't, they're like platinum rated. At platinum rated power supplies, they might be rated for 70% of their load. Something around that, that's when they're happy, 70 to 80%. So then you have to figure that math against it. So if we took like, let's just say 20% off of 2000 watt platinum rated power supply, we'd wind up at 1600 watts. So we needed special voltage and all kinds of other things to achieve what we can do with this individual 120 volt, 1600 watt titanium rated power supply, which can handle 94% of its faceplate load, and just all by itself, continuous operation, no trouble. So that's a lot of words, that's a lot of conversation to just say that we're sticking with 120 volt, 1600 watt, titanium rated, very important criteria there, power supply for our work here. And we're going to account for the slight difference in peak power with a 10% power cap on each of our GPUs, which should have very, very little impact on performance. But it's going to make everything fit in here really nicely, and it's even going to do us some favors on thermals, which isn't bad. Nobody's angry at that. Either way, that's the power supply. That's how these power supplies in particular fit into the Corsair 9000D. And just a mindful note for people in the future who are considering double 1600 watt power supplies. Either way, thank you guys. Take care.